This is my actual classroom, so I'll pan the camera around, but you're looking at my smartboard in my classroom, and the rest of the shop is over this way, so I have all my machines and whatnot this way. So, see. Hopefully that got caught on the video. All right, let's go ahead with the presentation. Okay, this is the presentation. So here we go. Okay, this is the introduction to robotics. I'm the instructor, Mr. James O'Flanagan, and today is October 28th, 2024. We are going to talk about an introduction to robotics today, and our tagline is Discover the Amazing World of Robots. A little history about robots. The first one was basically the Chinese abacus, and the second one was in the 1740s. It was their first computer, and it was invented by a lady by the name of Ada Lovelace. She's also the first computer programmer. She has a programming language named after her called Ada. Some technical people probably have heard of it. And all the way into the present day with the Tesla Optimus. Okay, introduction to robotics. Like I said, what is robotics? What is a robot? A robot is any mechanical and computer system that helps out human beings. That's it. It's a mechanical and computer system together. So it's a computer like cell phone, or the computer we're looking at here, plus a mechanical arm of some sort, or some other advantageous thing it does for humans, like build cars or autonomously drive. We'll talk about that in a moment, but a Tesla vehicle is most certainly an autonomous robot. Okay, the motivation and interest. Why are we talking about robots? Robots are everywhere. Well, first of all, this is a robotics class, but second of all, robots are everywhere, and no matter what field you go into these days, you're going to probably touch on robots somehow. Soon, autonomous robots will be ubiquitous in our homes. The Tesla Optimus just got launched 2 or 3 weekends ago. And that is, you can see here in the picture, a actual walking, talking robot like you see in a science fiction movie, except this is actually real. As it turns out, that Tesla you're looking at there is technically very similar to a Tesla automobile, like a Model 3 or a Model S. So it's not quite as big of a technological leap as you might think. Tesla basically just put a new chassis on their car, and voila, they've got a robot. So a lot of the computer programming for the brain that's all taken off from what they do already for their autonomous driving for the cars. So voila, they've got robots. So why does this matter? In maybe another generation or two, these robots will be part of the household, maybe part of the family. It depends how they get accepted and treated. So that's a whole other matter we'll get into in another lesson. I mentioned already what are robots. This example here on the right hand side, you can see here, is a 3D printer that we have here in the shop. And I should mention that the shop we're in here at Bedford High School has 3D printers, it has a laser cutter, it has lathes, it has all the woodworking tools you could think of in a regular shop class. Except we're doing engineering, robotics, and manufacturing. So robots are machines that can perform tasks automatically. Usually they're mechanical things. They can look like humans, animals, or even simple machines like a pencil or screwdriver, or it can look like a cell phone, which is obviously a very complex piece of machinery. Could be a mouse. That's a robot. It does mechanical things. Sorry. queued up the slides there. Okay, so that's a 3D printer. We're actually printing on it right now. You might be able to hear it in the background. Where do we see robots? We see them everywhere. A lot of us have Roombas. Roombas are autonomous robots. They do very sophisticated things, like they are able to see. And why I'm speaking in air quotes is that they use various ways to do that. Infrared, they use ultrasonic, but the point is they're able to determine what room they're in, what obstructions are out there. Some of them even have a guarantee of avoidance of doggy doo-doo. So that was a problem when these robots first came out. It would they'd run over a pile of doggy doo-doo and get it all over the house. But as the software got smarter and the robots got smarter, they're able to maneuver around it. Well, first of all, recognize what it is and maneuver around it. We see them in our factories. Autonomous robots have been building cars since the 70s, actually, making products better, safer, more reliable, and longer lasting. We've seen robots in hospitals assisting surgeons with surgery. We've seen nano robots do actual surgery themselves inside your actual anatomy inside your body. Entertainment, both science fiction and real, robots have been ubiquitous. Science fiction is one of my favorite genres of things to read and see movies about. So I like Star Trek and Star Wars. So R2-D2 obviously is a robot, but a robot that George Lucas might have made or used to film would be a set of cranes that move the R2-D2 and the ships around during filming of the movies of Star Wars and its sequels. Pixar, the Pixar animation studio that we all know and love today, was started by Mr. Lucas back in the 70s in his Star Wars studio. So that is the type of technology and robotics they were inventing back then. Steve Jobs made Pixar into what it is today, but it was the seed of it was in George Lucas's mind. Okay, how do robots work? There are three parts of a robot. First are sensors. Sensors are able to see the room, hear the room, feel the room. Actuators that's another fancy word for a motor. It's able to make arms move. And the brain, which is a computer, essentially. Okay, the sensors. I got a little robot illustration here on the right-hand side. We've got cameras, like in the eyes. We've got microphones, like in the ears. Ultrasonic sensors. These are something that's not quite an analogy to humans, but those things are able to sense distance. So they're ultrasonic, so you can't hear them, but it does use sound waves. Pressure sensors use the same kind of technology. Angle sensors are gyroscopes. Temperature sensors and touch sensors. Actuators, like I said, that's a motor. Actuators allow robots to move and perform actions. Actuators make robots helpful and interactive. So what does that mean? This is the mechanical part of what a robot does. Now, a robot doesn't necessarily have to have a mechanical component, theoretically. Hence the term bot, if you've ever heard that. That's usually applied in a software-only context. A bot is a piece of software that does something automatically. Useful or malicious maybe, but useful to somebody for humans. The actuators here are more of the classical robot setup that move something physical to do something useful for human beings. The robot's brain is a computer, and that's what you are looking at here on the right-hand side. That's an Arduino board, and we have those, a couple students are working on those now. The controller processes information from the sensors, and it decides something that, specific to do that somebody's programmed in there for the software. It tells the actuators, the motors, what to do, where to go, turn the wheels, lift the crane, drop the load, anything. Okay, fun activity. Let's design our own robots. And we've done this already with our Lego Spike. I'll go get that here in a second. Our Lego Spike. Uh, I and the students designed this tank. It's custom. Part of this was from 3 or 4 different Lego sets. So we had a great time designing this. You can see here one of the sensors. This is the brain. It's hard to see in this plastic, but the board, the circuit board is inside here. Actuator motors are connected to these gears here. So those are the motors, and these wires make everything go. It's just like a full-size Tesla. It's just like a Tesla, but made out of Legos. That's the kind of the lesson I've been telling everybody. A lot of times the difference between big robots and little robots like the Lego one here is that's it, nothing but size. The complication is the same, which makes these learning kits by Lego very, very useful because you can get a whole professional set of skills from just these Legos here, which is very cool. Okay, key takeaways. What did we learn? Robots are machines designed to perform tasks, useful tasks for human beings. They use sensors to understand their surroundings, actuators to move, and a controller to make decisions. The controller is a computer, so it's going to do anything that your smartphone or your computer can do. Real world importance. Robots are everywhere, and they're only going to get more ubiquitous. Your kids will know no different world than having robots about and talking to them very naturally. You stick a cell phone with a robot on it in front of a 4-year-old, and I've done this, and you say, here, please talk to my robot. She talked no problem. I did that same thing with my 72-year-old father, and he looked at me like I was not understanding me anyway. So that's why it's important. It's going to be ubiquitous. It already is for the youngest generation. So, okay. Discussions and questions? Okay, that's the end of the lecture. I appreciate it, Dr. Mopinga, and thank you for considering this as my lecture. Have a good day.